Hello students. So today we are going to discuss NCERT Exemplar questions of chapter 9, which is Amines. This is disclaimer. Okay, now let's start with the first question. Question is given to you that which of the following is a 3-degree amine or which is a tertiary amine. So 4 options are given to you. First is N-methyl cyclohexylamine. Second is triethylamine. Next is tertiary butylamine. And next is N-methylaniline. So first of all, you should know that how a 3-degree amine looks like. So if you see, the correct answer for this question is B1, which is triethylamine. Now let us see how it is the correct answer. First, if I move towards 1-degree amine, then what happens in 1-degree amine? Nitrogen is bonded to 2 hydrogen and 1 alkyl group. If I talk about 2-degree amine, then in 2-degree amine, nitrogen is bonded to 2 alkyl or aryl groups and 1 hydrogen. Okay, so in primary also it can be an alkyl or an aryl group. If I talk about 3-degree amine, then nitrogen is bonded with 3 alkyl or aryl groups. Okay. So now if we see the structures, we will see that triethylamine is a 3-degree amine. Now if I talk about first option, which is N-methyl cyclohexylamine. So this is how the structures look like. Okay, that is, to this nitrogen there is one this aryl group and one is this methyl group. So if you see, nitrogen is bonded with 1 hydrogen and 2 alkyl group. So this is a 2-degree amine. Okay, so nitrogen is bonded with 1 alkyl group and 1 aryl group. Okay, so in this case it is a secondary amine. Now let us move to the next part. Next part is triethylamine. Itself you can see it is tri. Tri indicates that 3 groups must be attached to the nitrogen. So this is triethylamine. 3 alkyl groups, they are attached to the nitrogen. So this is a 3-degree amine. Okay, so nitrogen is bonded with 3 alkyl groups. So it is a tertiary amine. Now, if we see the C part, which is tertiary butylamine, then what happens in tertiary butylamine? If we look at the structure, this is a tertiary butylamine. Okay, so if you see, this carbon is a tertiary carbon. Why? Because it is further bonded to 3 carbons. So this is a tertiary butylamine. And if you see, nitrogen here is bonded to 2 hydrogen and this alkyl group. So this is a primary amine. Okay, so nitrogen is bonded with 1 alkyl group. So it is a primary amine. Now if we move to the D part, which is N-methylaniline. Now if we look at the structure of N-methylaniline, then you will see this nitrogen is bonded to this ring, phenyl ring, and this methyl group. Okay, so if you see, it is bonded to 1 alkyl and 1 aryl group. So this is a secondary amine. Okay, so if you'll see over here, nitrogen is bonded with 2 carbon chains. So this is a secondary amine. Okay, so therefore if we see what is the correct answer for this question, then that is option number B, which is triethylamine, which is a tertiary amine. Okay, now let us see the next question. You have to tell the correct IUPAC name for this given compound. Okay, 4 options are given to you. So first of all, see, we have one double bond over here. Okay, see the groups which are directly attached to the nitrogen, follow the IUPAC rules and you will get the correct name. So if you will see, the D option is the correct answer for this question. Let us see how. So first you have to consider the longest alkyl chain as the parent chain, and others are designated as N substituents. Okay. Now if you look at this compound, then you will see this is the longest carbon chain, which has 1, 2, 3 carbon atoms. And the groups which are directly attached to the nitrogen, they are designated as N substituents. So you will see this methyl is directly attached to this nitrogen. Okay. So our longest chain is 3 carbon atoms long. So the root word will be prop. And whenever we are naming an amine, we replace the E of propene over here because there is double bond. So we replace the E with amine. Okay. Now if you'll see, methyl is the substituent which is directly attached to the nitrogen atom. So it will be designated as N-methyl. Now if you will see, there is a double bond which is present at the second carbon. Okay, so this is an alkene. So if you'll see the IUPAC name, it will be N-methyl prop 2-ene-1-amine. Okay, so this 2 shows the position of double bond, and this 1 over here shows that nitrogen is attached to first carbon. So this is the correct IUPAC name for this particular compound. Okay. So that is our option number D, which is N-methyl prop 2-ene-1-amine is the correct answer for this question. Now let us move on to the next question. Arrange the following. Amongst the following, the strongest base in aqueous medium is. So you have given 4 options. You have to tell the strongest base in aqueous medium. So if you will see, the C option is the correct option over here. Okay. So if you'll see, this is a 2-degree amine where nitrogen is bonded to 1 hydrogen and 2 alkyl groups. Now if we see, in waters, amines are more basic if their group adds electron density, which makes them easier to donate electrons. Okay. So if we see in aqueous medium, what does basicity of amines depends upon? First, it depends upon plus I effect. Okay, that is the electron donation effect of the alkyl group, which increases the electron density on the nitrogen. So with increase of plus I effect, the basicity increases. So you will see in aqueous solution, stronger bases have more plus I effect. And if I talk about tertiary amines, they have most plus I effect and primary one has least plus I effect. Because in tertiary, nitrogen is bonded to 3 alkyl groups. So they have highest plus I effect. Whereas in primary, nitrogen is bonded with only 1 alkyl group. So they have least plus I effect. So the order for basicity is first is tertiary, then is secondary, and then is primary. This is on the basis of plus I effect. Okay. Now, if we talk about solvation effect. Okay. Next, we'll talk about solvation effect. So, when a protonated amine interacts with water, hydrogen bonds form, which stabilizes the protonated form through solvation effect. So you will see that the protonated amine becomes stabilized by forming the hydrogen bonds with water molecules. So if you will see, primary amines, they have more hydrogen atoms which are available for hydrogen bonding. So that leads to the stronger solvation in water compared to secondary and tertiary amines. In secondary amines, we have only 1 hydrogen. Whereas in tertiary amine, we have no hydrogen. So primary amines where there are 2 hydrogens, they have more hydrogen atoms which are available for hydrogen bonding. So if we talk in terms of solvation effect, then the order of basicity is first more basic is primary, followed by secondary, and least basic is tertiary. Okay? Now moving forward. Now if we combine the effect of both plus-I effect and the solvation effect. Okay? According to plus-I effect, we know that tertiary is most basic, and according to solvation effect, we have seen primary one is more basic. Now we will combine both of these effects. So the order of basicity will be secondary, primary, and least is tertiary. Okay, so this is the order for basicity when we are combining both the effects. Okay, so if you look at the first option, this is a primary amine because nitrogen is bonded to 2 hydrogen and 1 alkyl group. So this is a primary amine. If we talk about B option, then you will see this is also a primary amine, but it has -I effect. Okay, because you will see that here a nitro group, okay, which is here you will see there is this NC group which is there. So this has a -I effect, which decreases the electron density and stabilizing the positive charge in the amine. Okay, so this has -I effect. Next, if I talk about this particular compound, then this is a secondary amine which has a combined effect of both plus-I and solvation effect. And if we see the C1, this is also a secondary amine with resonance of nitrogen lone pair. Okay, because you will see here nitrogen is bonded to this ring, so its lone pair takes part in the resonance with this ring. Okay, so it shows resonance stabilization. So according to the above given factors, you will see this, which is dimethylamine, it is the strongest base among the given compounds. Okay, so therefore option number C is the correct answer for this question. Now let us see the next question, which is NCERT Exemplar question 4. You have to tell which of the following is the weakest Bronsted base. So 4 options are given to you and you have to tell which is the weakest Bronsted base. So the correct answer for this question will be option number A, which is aniline. So first, if we talk about Bronsted base, what is a Bronsted base? So Bronsted base is a chemical species that accepts a proton, meaning it gains a hydrogen during a reaction. Okay, so it accepts a proton. So it is a chemical species that accepts proton. Now a compound must have a lone pair on its central atom to exhibit specific chemical behavior. Okay, so it must possess a lone pair. Next, if you see, more lone pair increases the electron density, enhancing ability to donate electrons, thus strengthening the basic character. Okay, so you will see more the availability of lone pair, more will be the basic character. So if we move further, we will see among the given molecules which are given to us in option A, which is aniline, the nitrogen's lone pair is involved in the resonance in aniline's resonating structures. If you'll see over here nitrogen, which has a lone pair, it is busy taking part in the resonance. So look at the resonating structures of aniline. Okay, so the lone pair on nitrogen over here is not localized, it is delocalized. So in anilines, the nitrogen lone pair is involved in resonance, which is reducing its ability, which makes it the weakest Bronsted base among the options. Okay, so you will see over here because the aniline's lone pair is less available. Okay, now if I talk about option B, C and D over here, then you will see the nitrogen lone pairs does not delocalized. Okay, that means you will see over here that the nitrogen's lone pair are not localized over here. So you will see more basic, so they are more basic. Option B, C and D, they are more basic than option A. Okay, so this is the correct answer, that aniline, because its lone pair is busy taking part in the resonance, they are delocalized into the ring, so it is the weakest Bronsted base. Whereas if you see in option B, C and D, you will see that the lone pairs on the nitrogen, they are localized. Okay, so they are more basic than option A. Okay, so therefore option A is the correct option. Now we will move to the next question, which is NCERT Exemplar question 5. So you have a reaction is being given to you. So you have to tell which of the following alkyl halides is best suited for this particular reaction through SN1 mechanism. Okay, so you have to tell that which alkyl halide is best suited in the given options to you. So if we look at the solution, then option number C is the correct answer for this solution, for this question. That means this is the best alkyl halide which is suited for this reaction through SN1 mechanism. Now if I talk about SN1 mechanism, then carbocation formation is the key. Okay, so if we talk about primary bromide, then primary bromide, they forms a stable carbocation. So if we see, this proceeds to the formation of the carbocation. So more stable will be the carbocation, more will be the reactivity towards SN1 mechanism. Okay, so if we talk about benzylic carbocation, which is in this case, so if you'll see, this is the most stable. Okay, and methyl carbocation is least stable. So if you'll see over here, in this case, we'll get a benzylic carbocation. So this benzylic carbocation will be more stable. So the order of reactivity will be benzylic, tertiary, secondary, primary, and last is methyl. Okay. So if we'll talk about then benzylic groups, this shows the highest reactivity. Why? Because there is resonance stabilization, which is followed by tertiary, secondary, primary and methyl based on carbocation's stability in the substitution reaction. So if we further continue the solution, so you will see that first, if you have, in this case where you have methyl bromide, then this forms a carbocation, which is a methyl carbocation. Okay, so this is a methyl carbocation and this is least stable because it has no alkyl groups to stabilize the positive charge. If you will see, there are no alkyl groups which can stabilize this positive charge. Now if we talk about this bromobenzene, then this bromobenzene forms a phenyl carbocation. Okay, now this is also unstable because the positive charge is on the benzene ring. Okay, and the ring does not provide much stabilization. Now if we talk about bromobenzene over here, then this in this case, which is a benzyl, this forms a benzylic carbocation. Okay, so you will see this forms a benzylic carbocation and this is more stable because the positive charge is on a carbon atom which is next to the benzene ring. Okay, and this ring helps stabilizes the charge through the resonance. Okay, and if you see the last one, which is ethyl bromide, so this forms a primary carbocation. Okay, it is less stable than the benzylic carbocation, but it is more stable than the methyl and phenyl carbocations because here it has one alkyl group that helps to stabilize the charge. Okay, so you will see more stable is benzylic carbocation. Okay, now if we see further, then we will see that this, which is a benzylic carbocation, is the most stable carbocation. Okay, this is because of the resonance stabilization. Okay, why? Because it is stabilized by the resonance. So therefore option number C is the correct option for this question. Now let us move to the next question, which is NCERT Exemplar question 6. Which of the following reagents would not be a good choice for reducing an aryl nitro compound to an amine? So these reagents are given to you and you have to tell which is not a good choice for reducing an aryl nitro compound to an amine. Okay, so you will see you have H2 excess in presence of platinum, LiLH4 in ether, Fe and HCl, and tin and HCl. You have to tell the correct option. So if you will see option number B, which is LiLH4 in ether, it is the correct answer for this question. Let us see the solution. So if we'll see over here, we have to tell that which is a good choice. Okay, so if you'll see that this compound which is given to us, when you treat it with in presence of H2 excess in presence of platinum, you get this aniline over here. And when you treat it with Fe and HCl, here also you get an aniline. And when you treat it with Sn and HCl, here also you get an aniline. But when you treat it with LiLH4 in presence of ether, you get such azo compounds. Okay, so if you will see, if you are taking an aryl nitro compound to an amine, when you are treating it with LiLH4 in presence of ether, you are getting an azo compound in this case. So if we look towards this solution, then you will see that the aromatic compounds, they react with LiLH4 to form azo compounds. So the reduction of nitro group to amino group, it leads to an azo bond formation between two aromatic rings via coupling reaction under suitable conditions. Okay, so nitro compounds, when it reacts with LiLH4 to reduce nitro group to amino group, so reaction occurs under acidic medium and product is an aromatic amine. So this reaction involves nucleophilic attack of hydride ion on the nitro group. Okay, so you will see in this reaction we have a nitro group. This is a reduction of the nitro group to a hydroxyl amine using LiLH4. So this is a nucleophilic substitution where LiLH4 reduces the nitro group to an hydroxyl amine group on the aromatic ring. Okay, now if you further see, two hydroxyl amine molecules condenses by losing a water molecule, forming a suitable hydrazine. Okay, so if you look at this reaction shows the formation of azo compounds from aryl nitroso compounds. Okay, if you'll see here we have N double bond O. Okay, so the nitroso group over here, it undergoes coupling with another aryl group in the basic conditions to form the azo compounds, which results in symmetrical azo compounds. Now this reaction is favored due to the instability of the hydroxyl amine under anhydrous conditions, which leads to this spontaneous decomposition and promoting the reaction forward to achieve stability. Okay, so you will see hydroxyl amine are unstable under anhydrous conditions. So therefore you will see option B is the correct option. Okay, so option B is not a good choice for reducing an aryl nitro compound into an amine. Now there is next question, NCERT Exemplar question 7. In order to prepare a primary amine from an alkyl halide with simultaneous addition of one CH2 group in the carbon chain, the reagent used as a source of nitrogen is first sodium amide, which is NaNH2, sodium azide, which is NaN3, then we have potassium cyanide, which is KCN, and last we have potassium thalamide, which is C6H4 CO whole twice N minus K plus. Okay, so you have to tell the reagent which is used as a source of nitrogen. So if you will see, option number C is the correct answer, which is potassium cyanide. Now if we talk about sodium amide, then sodium amide is the strongest base which is formed by the reaction of sodium with ammonia. So it dissociates in water to produce amide ions which readily abstract protons, making it highly reactive and useful in organic synthesis. So sodium amide is a strong base, and this reaction is not suitable for preparing primary amines as it leads to side reactions and lower yield, okay, which makes it insufficient for selective amine synthesis. Now if we talk about the reaction, then you will see this reaction over here. This involves the deprotonation of an alkyl halide by NaNH2, which leads to elimination via E2 mechanism, and this forms an alkene, sodium halide and ammonia. Now if we further see, we will see sodium azide and potassium thalamide. So they are reagents which is used in the preparation of primary amines through methods like azide transfer and thalamide synthesis. So first, if we see for the preparation of primary amines, so they do not add extra carbon, okay. So if we look at the reaction, then sodium azide, it reacts with alkyl halide to replace the halide with the azide, okay, and this forms an azide compounds and sodium halide. Now if we see with potassium thalamide, so if we see in this case, so this is a nucleophile which is used in a nucleophilic substitution reaction. Particularly, we use it in the synthesis of primary amines via Gabriel synthesis, okay, where it reacts with an alkyl halides under the alkaline conditions. Okay, so this is with potassium thalamide. Now, if we further move on, we will see the reaction with potassium cyanide, which is KCN. So this is used to prepare primary amines through Hofmann degradation, where an amide reacts with excess alkali to form the corresponding amine. So this is used for the preparation of primary amine, and this adds an extra carbon. Okay. So it introduces a cyano group which upon hydrolysis and reduction gives the desired primary amine with an extra carbon. So if you'll see, you will react alkyl halide with KCN, it will form RCN. Okay. So potassium cyanide adds a CH2 group via the nucleophilic substitution, converting an alkyl halide into an nitrile, okay, which further hydrolyzes to primary amine. So if you'll see, this shows the conversion of nitrile to primary amine using H2Ni in the presence of ethanol. So it involves the hydrogenation of the nitrile group to the primary amine. Okay, so therefore we will see that option number C is the correct option for this question. Okay. So thank you so much students for your attention. I hope this lesson was helpful to you. Thank you.